So as you can see here, we're talking about security. We're talking about how you can build your own products, leveraging the security pieces and manageability components of Knox. So just by a show of hands, how many of you here, I'm guessing you fall into two categories. Those that know a lot about security and are just interested in figuring out what we offer, and those that are learning about security and really want to know what they can do to improve security in their own products. So how many of you are in the former category, where you feel you're experts and you really just want to know what to do? Okay, and how many of you are the second category, where you're learning about security, there's probably a bit more to learn, and you want to see what else you can do and what else you can learn to know what to do next in your product? That's kind of what I guessed was going to be the case, so that's good. We prepped our material correctly. So a lot of you want to know a little bit more about security. So before we get into exactly what Knox offers and what Knox can do for you, we want to go through some of the basics of security. And so that you can understand, oh yeah, I totally forgot to introduce myself and Mike. So I'm David Thomson, this is Michael Grace, and we both work for the Knox team. And some of the things that we're going to be talking about are related to what developers can use of Knox. But it's also important to know what the fundamentals of security are and what you should think about when you think about security. So one of the things I think about is I remember something that happened about a year, 2 years ago to me. Totally true story. I woke up in the middle of the night and to some noises, and I noticed some movement at the end of my bed. And there was a guy there. He wasn't supposed to be there. This is a guy who was not
important detail there.
Yeah, this was not. This is a guy that had broken into our home, and was there at the foot of the bed. This is something that you don't ever want to have happen to you. But in this case, cutting the story short, but cops found a guy. They weren't sure if that was the guy, and ended up having to let him go. And I never really knew. And so, but what did happen after that is I started to think about, crap, what do I got to do to make my house secure? What do I have to do to feel secure in my own home? And what can I do to protect myself? And just shoot out a couple of things that you think of when you think of things that you would do in my circumstance to try to protect yourself better in your own home. How many of you can think of something you could do at all? Anybody? Luke? Yeah. Change the locks, okay. Sorry? Gun in the nightstand, okay. What else?
One deterrent.
Sorry? Put sensors, exactly. So as you can see, some of the things, yeah, we already went through this. So some of the things you can do to help protect guys from breaking into your home are things that you can do in a digital version to protect yourselves on your mobile devices. And I know that's overly simplistic, but let's go through a little bit of details here. So here's a physical world and digital world comparison. I know it's not perfect, and you could probably nitpick on some of these, but door locks are some things you could do. And of course, in the digital world, you have some things like access control, authentication, and encryption. You have document safe and certificate storage. There's all of these different things that you can think of as being things that make sense in the physical world, and in some cases, they even use the same terms in the digital world, like backdoors. Literally, a break-in in your back door could be the equivalent in the digital world of having a backdoor in your operating system. So once you've got an understanding of what some of the goals are with security, know what the problems are, know when they happen, prevent bad things from happening, and control your circumstances and your surrounding. So what do we do when we're talking about how to actually do this in the digital world? Well, one of the first things we always hear is, as a question, hey, is our product secure? Are our phones secure? Have we built something that is secure enough? And defining security is really important. I'll bet that Mike has had to answer that question quite a few times. He's head of security for Knox. And there's a lot of times when people ask something without even knowing exactly what they're asking. Mike, can you think of any times when someone has come to you and said, hey, is the system XYZ secure, without giving any more detail than that?
An awful lot, yes.
And so what do you normally do in those circumstances to try to help them figure out?
Ask, well, secure against what? What exactly are you worried about?
Yeah, and so in the same way that you have to figure out what matters to you, you have to define what we term as a threat model. So that means that if you want to protect your phones completely, you could provide a bodyguard with it for free, right? So you get your phone and your bodyguard with it. And that would provide a certain level of assurance, but that's way beyond what most people want, and it would be very expensive. But there's a spectrum on security, and you have to understand what matters to you. Is it the protection of your data? Is it the protection of your data from insiders, from outsiders? Which ones are the most important, and what kinds of technology do you need to use? And then finally, in order to do it the correct way, you want to make sure you use the right technology. And so that's one of the ways we try to help you with Knox, is building modular components that help you with security that you don't have to spin your own version of. You don't want to have to worry about all these different cryptographic algorithms and what options and this and that. As long as you're given the tools to do it in a secure way, and you're given pieces that other people can't do for you, then you have some differentiation with Knox. We're helping you out, right? So what is secure enough, though? Here are examples of things that probably aren't the perfect examples of security. In the first case, we have a bike with some locks. You know, one lock is good, so more locks is better, right? And in this case, you can see that not only is this not more secure, because most of those locks don't even go to anything, but the bike itself would be impossible to ride. In the same way, computers or technology that have too much security, again, air quoted, can actually be very, very difficult to use. I remember President Obama saying that his phone was so hard to use because it had to have so many restrictions that he couldn't do a whole lot with it. And the example in the middle, of course, is a very robust cast iron or whatever they make submarines out of submarine, but of course has a screen door on it, and of course that's going to do you no good once you're underwater. And in the final case, this one may be a little more confusing to you, but hopefully most of you get why the one on the right is absurd. Why on earth is more locks not better here? Can anybody say? How many locks do you have to break to get through the gate? Just one. Or zero, someone said zero? I don't know. I guess you need bolt cutters. That's all you'd have to do, which is a good point. You wouldn't even have to have a key. But all you have to do is unlock one lock and you're done. So all the extra locks don't do anything. They just make it harder to maintain and more expensive. So we want to understand the basic idea of chain of trust so that you can understand what it is that we're providing as a platform and what it is that you should be investigating when it comes to the device and OS manufacturer. You know, when we provide you something, what is it that you need to know about what we provide to you and what claims we provide to you? So the idea of a chain of trust, if you think about the chain over here, all you had to do is break any link in the chain, of course, and you're done for. And in the same way, the chain of trust in a computing platform, like a mobile device, includes the hardware that turns on. It includes the bootloaders that have to load the operating system, the kernel, the base OS, the middleware, the application layer, your app that's running on top of it. There's all these pieces. And if you're trying to develop a solution, for example, that is an app, and it's a security-focused app, or it's wanting to at least have some data protection guarantees, you can't do that by yourself. There's no way to do that. If you run an app on top of something that's just, leaks like a sieve, then it won't really matter what you did. And so in the same way, you want to make sure that what you're building on top of is a good foundation. And so when we say something like hardware root of trust, what that really means is that when you build your solution on top of pieces that we expose to you, those pieces are protected by other pieces, and the base of that trust chain is hardware. That's what we mean when we say hardware root of trust. So let's talk about what Knox is, now that we understand the basics of security. So just a reminder, you got to figure out what matters to you, and you figure out what technology can help you get there without it being too hard to use. So the Knox product family includes three main areas. Some would debate exactly how you divide this, but this is how I do it. So the first one is deployment services. This includes solutions that help people get devices into employees' hands without requiring that an IT guy unbox every one of them and then configure every one by hand. Right? So deployment services helps you allow a large enterprise be able to, for example, buy in bulk devices, assign those by IMEI to employees, and have it so when they're unboxed, that actually starts provisioning policy for them. In addition to deployment services, you have the Knox platform. That's what we're going to focus on here. That's what we do most of. And that is the platform that is underneath deployment services and the other Knox exposed software solutions. And it's also what can be tapped into by developers. And that platform is meant to give extensions to Android that help cover some of the gaps in security and functionality that enterprises or business users care about. And so, as you can imagine, a lot of manufacturers, people that write OS and that create hardware, make a lot of money by selling to consumers. So it's not really at the top of their agenda to say, hey, what can we do to make sure that all the business use cases are covered? And so Knox is the division of Samsung where we focus on those types of use cases. And what we want to highlight here is that we really do have a lot of things to offer that are differentiated for enterprise, not so much for consumers. So the last one is Knox customization. And the key thing there is that for really high security cases where specific either agencies or high security customers or military deployments, they want very specific things, we can actually expose to them a way for them to modify the firmware or OS itself. And they can get their own image for their devices that are strictly controlled and locked down to exactly what they want, things removed, things added, whatever it may be. You need a special driver to connect to some military hardware you got to do. That's possible as well. So these are the types of things that are possible with the whole family of Knox. But let's talk about the platform itself. So we have The focus areas of Knox are passive or active hardening that you don't have to worry about. It's just happening in the background. And it's something that allows you to take advantage of the IP and the technology that we have. An example of that would be our real-time kernel protection. I won't go into the details there, but it's in part of the white paper, which we have hard copies of and a link to at the end. It'll go into details to what kinds of protections this actually gives you. There's manageability focus, which is probably the bulk of it, which is how do you get the devices deployed in a way that that will allow you to have the right policies on the device, control the experience, and make sure the end users are using it in the right way. And the last one is certifications and compliance, meaning if you want your solution to be deployable, a lot of times you have to meet a certain bar. And to be able to meet that bar, you have to know what the requirements are and build to them. And in many cases, we expose controls or features that allow you to either do that or help you already start getting in that direction. So those are the areas that we focus on with Knox. And it's important to remember where we all fit in this. So obviously, we build the platform. We're the top one, Knox platform and APIs. After that is the end customers, which all of us are helping to support. And then there's device administrators, which is kind of like a user, but they're the ones who are trying to provision policy and figure out what they need to do in their deployments. And then you guys, the solution providers, the people who are trying to use everything available to them to please the end users and device administrators, just like we're trying to do. And so you guys fit into this category at the bottom. This can be universal endpoint management solutions. It could be VPN client vendors. It could be some people I even know who are in the room who do special deployments for military that are just crazy cool, off the beaten path kind of ideas. And there's a lot of things you can come up with if you're creative to help support various types of use cases. So the goals with your security solution should be making it easy to manage and use, like the bike. You don't want it to be hard to ride. You want to make sure that the data doesn't leak. In the end, most of what it comes down to is data protection. And then you want to make sure that there's visibility and status given to the right people, the end users and admins. As an example, if there's something funny going on with a open Wi-Fi access point that you used, and if there's some way to determine this from a solution you guys provide, using some of the controls on our device, you want to let the end user know that they need to alter their behavior and stop using this or change to something else. Or in an admin case, you want to expose some of the metadata associated with what's going on the device so that an admin can know what to do when certain devices are at risk or when either an accidental or malicious exploit has occurred or compromise of your data. So this is a list of some of the examples of the things that the Knox platform provides. So these are different areas, and even if you don't know what all of these are, go to the white paper. We've got the white paper. That's for afterwards. But each of these expose a set number of either features or controls or protections that you can take advantage of from the Knox platform. And just to cover a couple examples, the first two here, we have remote device attestation, and I think Mike will also go into a little bit of detail here, and device policy restrictions. So by a raise of hand, how many of you have heard the term attestation and know what it means? Okay, so that's good. So we have something to give that most people don't know about. That's good potential for helping you guys out. So attestation, just like the name implies, allows you to attest to something. So try to think about what you'd want to be attested to with respect to your phones. What do you want proven to you? Usually one of the things you want to know is that my device is in a good state. And you don't want to have the one reporting on that be the same OS that you're worried about being compromised, right? So in other words, if someone found a hole in Android somewhere and they were able to compromise that component that told you how it was doing, it would just lie all the time, right? It would just say, yeah, sure, everything's great, hunky-dory, nothing going wrong here, right? But you want to make sure that what you provide as a security mechanism to prove the state of the device is not trusting the answer to the same thing you're trying to protect. And so we'll get into a little bit more detail in an example he's going to give at the end. He's going to cover case study items and examples of deployment solutions using Knox, and one of them will probably cover this. And then the second one I have listed here is device policy restrictions. This is the bread and butter of what most people think about when they think about a deployed device that is managed. What does it mean to manage it? If you think about an end user, he just has a phone, and we've built a lot of cool stuff for him, and he can do anything he wants on that device. The whole point with a managed device is to say, well, not anything, please. And you carve down a smaller subset of what is possible with that device, And you make sure that they use it in a way that is compliant, whether that be they have to put in certain size passwords, or they can only connect over certain networks, or the only way you can get business data is over a specific network. Those types of restrictions are very important. And while there are basic ones across many different OSs, we have ones that are granular enough to cover lots of cool use cases that will allow you to build neat solutions that are differentiated. And then there's a bunch more here, which you can look into on your own. After that, I wanted to cover, that's the basics of security. The basics of what the Knox platform is meant to do cover exposing controls to developers that will allow you to build solutions that meet the needs of either the usability, interfacing with enterprise systems, or security claims for your business users. But some of the resources, so we have one website, which is samsungknox.com, and this has resources for developers to help them build solutions that take advantage of some of these APIs and gives even guides as to how to do it, as well as SDKs. The SDKs themselves actually are in another website. So Samsung Knox is higher level. And then if you go to the Samsung Enterprise Alliance Program, that's SEAP or SEAP, this is another website that you can go to that gives you a lot of information. So as you can see here, there are drop-down little things here. And in the next one, you'll see that here we've clicked on Develop, and we've clicked on About Licenses. Knox itself is a platform that has couple licenses. I won't go into the details here because here's how you get to it. There's a couple licenses, free, paid, depending on what kind of features and functionality you want to do. But all of that is listed here, and even how to get those licenses is listed here.
Oh, and by the way, the links to all of these are going to be at the last slide.
Yep.
So you don't have to worry about finding any of the things.
Yeah, the eye test of trying to read that. Don't worry about that. So that'll be at the end there as well. All right, and so this is an example of if you clicked on in the last page, develop, and then Android right here, you get a list of OS, or not OSs, but of different SDKs. There's a VPN SDK, a standard platform SDK, among other things. And this is an example of one of those SDKs. Classes over here, APIs listed over here, the standard thing, what you'd expect. You don't just have to dredge through this. We do have developer guides as well that will link to this, as well as a white paper, which we have a physical copy of you can grab if you want at the end, or a link that we give at the end of this to that white paper as well. And it links to this kind of stuff too. So, and here's the white paper. This is the white paper in web form, breakout sections for each of these. Every item here is differentiated. That means that we're not just listing a lot of things everybody does here. Everything that you find as a breakout from every one of these subsections is something that has some differentiation where we give you something you can't find other places. And so that's one of the main things we want to make sure you understand leaving here, is that Knox means security, Knox means manageability, and Knox means granularity. In other words, there's things that others don't cover because they're really focused on consumer, and if you want to focus on business use cases, we've got a lot of things that can help you out. And that's it for my section. So now we're going to go into some time. Mike's going to cover some of the case studies of how you can actually use Knox and examples of solutions that were built to leverage what we have. And with that, there you go.
All right, thanks, David. So I'm going to talk about how some of our partners used our SDK in practice and some of the problems that they thankfully surmounted. So there's a lot of different things you can use our SDK for. I am deliberately just keeping it to what the case studies are. Basically, the sky's the limit. We want to encourage creativity. But first off, let's just talk about the traditional UEM case, right? There's an enterprise, they want to manage some number of devices. And in this case, unbeknownst to them, somebody in the supply chain did something to those devices before they even reached the customer. And so when they're trying to provision the enterprise sort of applications and secrets, if they had provisioned them, they would have leaked to a third party. But we have an attestation SDK, which, as he had mentioned, handles the idea of externalizing state so that you can judge before you test the waters on whether giving that device these secrets would be a good idea. Then the second use case is single-purpose devices, embedded devices. Basically, there's a number of bespoke devices out there in the world today that will do just one thing, like an ATM, or in this case, an Inflight infotainment system. And displacing those devices with commodity devices with much more recent technology, unfortunately, those devices, the ones that we ship, have so much functionality that not all of it is appropriate to the use case. It can, in fact, be a risk. And so our restriction APIs allow you to go and pare down the functionality of the device to meet the threat model of that particular use case, enabling it to be used in some fairly unconventional places without hardware changes. So let's go through this first first example. So fundamentally, enterprise mobility is about allowing people to be productive on the road by giving them access to things that they normally would only have access to within the corporate firewall, on the site, et cetera, which to an IT security guy is terrifying, right? So what you want to do is make sure that if you're going to open up this access, you know who has access at any given moment. So making sure that the secrets will go to the right place is basically the story here. So if we talk about the supply chain compromise case, and I'm not going to get into exactly who, but you can imagine, there's a customer that you want to reach. You've got you're a partner of ours, and you've built an excellent UEM solution. The problem is that when they want to buy devices, and they're going to buy potentially a lot of devices, they're being produced in a very secure factory, but they've got to actually reach the customer. So there's a whole logistics chain. There's like resellers or even maybe some of our warehouses in the middle there. There's a distribution channel that will bring things to and from those warehouses. Let's say that this just represents a pilot where it's going to go through this one channel, some limited number of devices. There's going to be some guy in IT that's going to then go and make sure that they're provisioned correctly. But the pilot goes successfully. And so you now have an opportunity and a problem at the same time. The customer is very interested. And let's say the customer is a global organization. One supply chain sounds like a very bad idea to that customer because if there's a warehouse fire, then maybe they can't get phones for a while. So they set up some additional, if they're global, maybe their Italian branch has one, et cetera. Additional resellers, additional warehouses, additional distribution channels come into play. Then, on top of that, this organization has a number of workers in the field. Perhaps they have some satellite offices that only have 5 people. They're not going to have like a pallet of devices come in and then get onboarded by IT. And it would be very expensive to go route it through something else. So they would really like to just have these guys in the field go to a big box retailer, pick something up off the shelf, and then just follow some instructions to onboard the devices to their network. So my job, a large portion of my job, just boils down to asking the question stridently and as creatively as I can, what could possibly go wrong? So in this case, there's a lot of people that are going to be touching these devices, and any one of them could be malicious. There could be a compromise pretty much anywhere. And what happened was some of these devices, they go through that chain, and when they reach the customer, never mind necessarily how, the software that was on there was not in the state that it had left the factory. So what went wrong? All right, first off, don't blame the supply chain. There's a reason that these are commodity devices. We want to have big scale, low latency, get the devices kind of wherever, right? So if we're talking about chains of trust, we don't want to go and vet every individual person in that supply chain. We want to just minimize the amount of things that we have to actually trust once we've gotten to the point where we're going to be onboarding that device. So the real question here is that if you can't tell whether the device is in a good state, you could provision secrets onto it anyway, and then we'd have a leak. All right, so how do you provision secrets safely? Basically, it boils down to this statement. We can decompose this statement to come up with the pieces that we're going to need. Secrets need to go where they should and only when it's safe to do so. So where they should basically boils down to a question of identity. You want to be able to say that this is employee A, and he's been issued we'll give him a note device. We're being very kind. And that device, at the time that we're provisioning the secrets, can prove that it is in we'll call something a valid state by some measurements. So there's a protocol for this. It's a simple 6-stage process, as you can see. I am not going to go through all the cryptography involved in here, but at a very high level, it basically boils down to the same sort of process that you would go through to get a beer at a bar. You walk up to the bar and you say, "Hi, please provision me a beer." The guy behind the bar says, "I don't know that you're actually 21. Could you provide me with some proof from an accredited authority that you are in fact 21 and that is the correct person?" And so you will provide that credential. They will inspect each thing, kind of squint a little, look at you, look at the picture, look back at you, look at the date that's on there, look at the date behind the bar saying you have to have been born after this date in order to be born before this date in order to be able to drink. If all that checks out, then you are provisioned a beer and everybody walks away happy. Basically, that's what attestation is. But what David had got at is that it actually matters a lot where you perform the attestation. Because, I mean, this may be shocking, but on the internet, it's really hard to tell what somebody looks like, right? So if you ask over the protocol to provide the proofs from the thing that you're not really sure whether it's okay, you're doing it wrong. So basically, the way that we've handled this is that we have a notary inside the device, to use our real-world example. Basically, there's a small piece of code that's running at a higher assurance level called a trusted execution environment. When you do the generate proof step here, that is being routed through something much smaller than Android that has a higher level of security assurance, such that in the case of our supply chain compromise example, the attacker was able to compromise Android sufficiently that they might have been able to get some secrets. However, because the server asked first, can you provide proofs that you are in a good state? The trust zone, the trusted execution environment I was mentioning, our notary, provided the measurements that it knew to be true, which did not match the expected measurements from the server. And so therefore, we were able to block provisioning the secret. The customer was very happy with the solution provider and with us. I can't really speak to the distribution channel. So let's go through a second example here, single-purpose devices. So, you know, it's election week, right? And so I hope a lot of you, if you're American, you voted. How comfortable would you have been had it been just a off-the-shelf tablet there trying to accept your vote? I mean, it has all the functionality necessary to do that. You know, it's actually probably a lot nicer than any electronic voting machine that I've ever seen. But there's a reason that we don't use that for voting machines, ATMs often, MRI machines, or especially the president's nuclear football, the one with all the launch codes, even though it can provide the affordances necessary to get the job done. So let's break down the intuition here. So like, what's wrong with using just an off-the-shelf device in those circumstances? Well, tablets were designed to do a great many things for a great many potential use cases. We don't necessarily know when somebody walks into a store what they're going to want to do with that device. And whatever feature they're looking for might be the differentiating factor between buying our tablet or somebody else's tablet. So there's definitely a pressure to say, let's come up with more creative ways for people to use devices, which is great for the consumer use case. But that means that we have to have a very permissive threat model because we're not sure how the device will be, we'll call it deployed. Now, when you talk about a single-purpose device, on the other hand, all the examples I gave you are in some way related to a regulatory market. And that means that they're designed to do only one thing, and furthermore, there are actual laws preventing them from doing any more than that one thing. You say, you must do this and nothing more, which is very much so at odds with the threat model that the tablet was designed to be used, again, most of the time. But thankfully, due to Samsung's scale, the enterprise use case, when you have so many people buying our devices for so many reasons, there's a substantial number of them that are enterprises. So what Knox allows you to do is to configure something that's off the shelf, just hardware, such that it can be used to meet these enterprise threat models. So just to give you an example of this, in-flight infotainment. How do you guys all feel about the quality of the screens that are in your average transcontinental airliner? I mean, compare that to a tablet, right? I mean, 1080p is all you're ever going to need. And you might have to push on it a little bit, and the guy in front of you might be a little bit annoyed when you're done, but you can select the things that you need to do to watch your movie. It turns out that these are actually hugely expensive for a variety of reasons. Each one of those seats is $10,000. And each one of them weighs on the order of 13 pounds. So you do a little multiplication, 13 pounds times 300 seats. And the overriding factor for airline operating costs is fuel. There's a great pressure to replace these with something else. So on a lot of domestic flights, I know that they've already gotten rid of them for bring your own tablet. But if you want to offer an experience for, say, a business class customer where you don't have one of these and you can give something a little bit nicer, perhaps we could interest them in a shiny new Tab S4. Where that one is $10,000+ plus, we could replace it every year for a few $100 and have a much nicer experience. The problem with that is that if the airline wants to provision these, then some of the things that may be acceptable in a bring your own device case, the airlines don't want to be seen as condoning. So my last flight to Minnesota, I had booked way late. I'm in the back of the plane, and some guy decides to watch the Avengers. And I know that because I got to listen to the whole thing, right? That was not a really great experience, no. So imagine if you issued that to somebody who's in business class, and maybe they've had a little bit too much to drink, whatever, and if speakers are in that tablet, if they can use the speakers, they could disrupt other people on the plane. So the gentler thing to do is to say, let's go and knock out the ability to use the speakers. And the thing that's interesting about this is we were able to do this without having to, this is not a new requirement to us because we got it from a much higher security customer. I'll get into that later. So let's look at it this way, right? There's some volume control logic. And under Android, there's basically multiple volume sliders. Depending on your context, when you do something to change the volume, you actually are changing a different setting. So if there's nothing plugged into a headphone jack, generally changing the volume will change the speaker volume. If something's plugged in, it'll change the headphone volume, et cetera. So when you're taking a single-purpose device and you're just trying to set it up such that it will handle watching movies, playing music in this sort of kiosk-style environment on a plane, you'd say, well, first off, we have to make sure that the video and music applications can't change the volume. Like, you could approach it from this perspective, right? I'd say, oh, but unfortunately, the ones that come on the device, they don't really know about this, even though they technically could. Again, consumer application, and it's not really necessarily worth it at that level. So we'll just rewrite those. It'll be fine, right? But what about the actual physical buttons on the side of the device? Those interface at a much lower level. And actually, the part that's the hardest of all this is the settings application itself. So just to get into why, the settings application is part of the Android OS to the point where you can't just disable it. So I've seen a lot of deployments where they try to hide it. And this is something that came up during the discussions about this. So if you try hiding this, you get into a situation, let's say in the modern era we have all these intelligent assistants. And you don't think to block the microphone because it wouldn't do anything, right? But if somebody can say, OK, Google, turn up the volume, then they could actually actuate through the settings in order to get this thing done. It gets more complicated, though. We can knock that out. Sure, let's just get rid of any intelligent assistants. We're going to block the microphone. Everything will be great. The two best sets of testers I've seen externally are in schools and prisons. Because you both have a captive audience, and we have a bunch of educational tablets in there. If you leave a single UX flow unaccounted for, somebody will find it so that they can, as opposed to doing educational stuff, they could maybe play a game. So there's many additional things. I've seen people get it on some devices in the distant past. You could actually get to the settings directly from the lock screen in a way that wasn't really visible, but again, diabolical testing. Similarly, dialer codes. I think David had a good one recently. Anyway, if you try to go and approach it at that level, it's just not going to work. So I think I advanced one too far. The appropriate way to handle this is with a policy being enforced actually at the level of the control. And to think about why that is just so much better, just go back to the idea of change of trust. So you basically say there's a small piece of code that will actually update those settings and will tell the hardware to change what it does. So if we can tell that about the policy, then whatever else goes on anywhere else in the system, whatever weird UX flow you find, something might try to change the volume, but it won't go through. So this is all about minimizing the things that you have to account for. So seems like we ran a little bit fast here. That's great. Plenty of time for Q&A. What I'd like to sort of summarize, what I'd like to leave you with, is that we are an excellent toolkit for reaching enterprise customers. And the reason for that pretty much boils down, again, to a notion of scale. We ship a sufficient volume of devices to a sufficient number of places that we have to cover a lot of these unusual use cases. Oh, I'd actually forgotten the reason that we'd actually done volume control and brightness. I did not realize brightness was a matter of life or death, but some of our military customers didn't want to have a soldier get a text when they're right next to the enemy. That could be a very awkward situation. And so we are enforcing a lot of those things for those purposes. Anyway,
Yeah,
I guess we're over to Q&A then. Ask us anything.
no questions mean we did it perfectly, right?
Wow. Looks like we got one.
Since you just mentioned about brightness, in the earlier versions of Knox APIs, you had to set a default activity like timeout for the screen, and the brightness API was only available in custom Knox. Is that now available in standard as well, or we still have to go to custom Knox?
What's happened is that we used to have a number of different SDKs. So the custom Knox was used for customization, and then there's one for MDMs and one for ISVs. There's now one SDK. So all the functionality should be available just broadly, assuming you have a license.
Okay, thank you.
And as a general trend, what we like to do is we find that those items that are commonly requested in customization, we move into the standard SDKs. An example of that doesn't just relate to our division that works on the platform is that we had commonly deployed changes to our devices for military use, which we eventually had an internal other division of Samsung say, hey, you know what, let's actually use some of the other APIs, request some changes from the platform guys so that we can accommodate that. And then we'll build our own solution on top of that that will allow us to have a tactical edition of a Samsung device that we can sell directly to the military. And so that was something that they were able to do, and then obviously make their own money on top of that. And so that's an example of something that where you, and it's a good point. We should make sure that you understand that not only do we have something, but we love security and we love this kind of stuff. And if you have suggestions or if you want to provide insights into what customers are actually needing, we'd love to stick them in either the SDK or make sure it's available and understandable to the people doing the customization projects. Unlike many other vendors, I think that's the strongest differentiation of Samsung and the Knox team is that unlike many other vendors, we're willing to listen and do things in order to accommodate even sometimes smaller deployments, but where we think that it can scale over time to open new markets based on the requirements of these specific customers, especially military. But it can be anything, regulated, federal, finance, healthcare, anything. And if you're creative, you'll probably come up with some ideas you can share with us.
What's the future of Knox? With the
wow.
evolution of Android, because we noticed that, like, starting Android 9, the device admin feature will be deprecated. We can only use device owner. So it's getting harder and harder to get the features from Google. So is Knox going to supply those missing features in the future?
So there's a couple things there. So one, I have to say this, but the fact that Google has said, let's go do that thing that Samsung did because it seems to have worked really well and we'll make that be something everybody can use is flattering, honestly. So the fact that they were able to take some of the technology we built with SE Linux and SE Android, take the way in which we approached it with the workspace, which is a specific piece of the platform. Knox or the Knox platform is not the workspace. It is much bigger than that. And the part you're talking about is just that container. It's the app isolation container. And so the fact that they are basically copying us and exposing it to everybody is something we actually worked with them on to make sure we weren't stepping on each other's feet. But we think that the differentiation from Knox is largely in these newer use cases. And as an example, if we went back to the list of, I don't know if we'll be able to find it in time, but there's a list of all these Knox features. One of them, as just an example, is network platform analytits. This is an example of something that we've been getting some, one back there. We've been getting some feedback on wanting something that allows enterprises to see what's going on a device. And I think NPA is the beginning of a lot of other areas where we can take our expertise and our fingers deep inside the OS and being able to see the states of things and expose those in abstractions that are easier for other solution providers to use. An example here would be that you take, what does network platform analytics do? It allows you to take metadata about network traffic. An example of that would be if I see at a switch that there's traffic that's of concern to me, there's only so much I can do. I can only say, well, I know the IP, I know the device. That doesn't give you all that much. But if you can take and say, I have metadata associated with that that tells me which application generated that traffic, what's the hash of that app? Is it a modified version of the Facebook app? Is it a fake app? Is it one we just deployed that's in test phase? What was the DNS server used to resolve the IP address it's communicating with? What's the package name? Who launched that process? Anything. All of those things help give insight. And I think a lot of the future, I know this is cliche, but a lot of the future is using machines to do jobs better. I avoided saying AI there, but finding a way
and then you
to
immediately said it.
Yeah, I know, it's totally ruined it. But finding a way to use the data that's available to us to find patterns that'll help you do your job easier. In other words, if there's a problem, tell me about it earlier. Tell me what to do about it. And then help me not have to flip too many switches or write too much code to do it. And so NPA is an example of something where we're trying to leverage the insights that we have in order to allow developers to write their own solutions that can do that. That can take that information and build on it. And for example, Cisco already has implemented a monitoring agent that links with this, and their StealthWatch client can expose that to customers. That's just as an example. So I would say AI or machine learning-based analytics, more visibility. I would also say granular controls that move in the direction of trying to simplify, not clutter, the device admins' minds. You don't want to make it so they just have, well, you have 1,000 APIs, we have 2,000, so look at how amazing we are. You want to find a way to help group them in ways that make sense and help them get to what their end goal is faster. And so we're trying to find ways of exposing simplified controls and simplified, high assurance policy restrictions. And an example of that would be finding a way to make sure that when you do the disabling of camera, that you're doing it at a level that's so low that you're nearly guaranteed no one can circumvent it, as opposed to what everyone else is doing. And that requires the kind of insights that we have, the motivation to do these kinds of things, which most OEMs don't have, and the visibility and being able to tinker with all levels of the hardware and software stack.
I'm just going to summarize it very, very succinctly. He talks a lot, I do too. Basically, the future is these two things are actually very important to us. And while we think that we're better than a lot of the other guys out there, actually pretty much everybody out there, we still think that we can improve on some of them. So what he's saying, we'd like to have a very positive feedback loop on what's going on. The changes to device administrator, that's more or less just how you go about doing the thing. If you have a specific thing that you're having a problem doing as a result of some of these changes, please talk with us after the session.
Yep.
Cool.
Because to be honest, sorry, I do talk a lot. A lot of the things that you're being told from other OEMs is, well, this is what we built for consumers. Figure out how to use it that way. Sorry, we're not like that.
Hey guys, I guess I'm sort of rebounding off his question. With Knox and the future and sort of the monetization or the selling point of Knox, what do you guys see it as? Is it really that the security aspects is what makes the premium part of Knox, or are you saying we'll think of cool features and we'll put it in there?
I think I'd put it this way. So security is it's kind of the price table stakes for a lot of these kind of use cases, but you still have to be able to do something useful with that, right? So we want to enable other people to build useful things. That we're talking about all partnership stuff here. We're also doing some things as a first party, right? For example, we have just recently launched something that has to do with loss prevention for carriers. We've never done something quite like that before, but it's pretty easy to say we have the security chops to do it, and they just need to have a way to manage it properly without having to do a lot of integration.
And the key thing to remember is we don't just make phones. So
Yeah.
a lot of the technology that we build hopefully will create a standardized ecosystem for building secure solutions, especially in the future when we have devices that are low cost and don't have a lot of the chops to do a lot of the checks and have a hardware backed this and that and whatever. You need a standardized way to expose the right controls that developers can use across the board for Samsung devices.
Sounds like we might have time for one more question. After that, I've got about 20 of these glossy white papers. I mean, if we run out for whatever reason, you can get the links.
And that's.
So anyone else want to know anything in front of the studio audience? No? All right. Well then, thank you all. You've been a great audience.
Yep,
We'll be
that's it.
around after.
Thanks.
Cool.